In this video, we're going to discuss operations with radicals or square roots, the same thing. We're going to go through addition, subtraction, multiplication, and division, but we'll start with addition. You can only add two radicals if they have the same radicand. They must have the same radicand. The radicand is the thing that's inside the square root. It's what I'm writing in red. That acts as the radicand. The thing that would be outside, let's say it would be 5 square root of x or 5 radical x, that is the coefficient. If two radicals have the same radicand, then you can add their coefficients. So then you can add their coefficients. If two radicals do not have the same radicands, then you can't add them. Let's look at an example. Let's say I have the square root of x plus 2 times the square root of x. If there's no coefficient, we assume that it's a 1. So 1 square root of x plus 2 square root of x. Since they have the same radicand, they both have a radicand of x, we can add their coefficients. So 1 square root of x plus 2 square root of x, 3 square root of x. Let's look at another example. Negative 5 radical y plus 6 radical y. Radical and square root mean the same thing. So this could also be negative 5 square root of y plus 6 square root of y. Since they have the same radicands, they both have a radicand of y, we can add them. We can add their coefficients. Negative 5 plus 6 is 1. So negative 5 square root of y plus 6 square root of y is 1 square root of y, which is the same thing as just writing the square root of y. One last example for addition. Let's say we have negative 20 square root of x plus 15 square root of y. Since these two radicals do not have the same radicand, the radicand of the first one is x, the radicand of the second one is y. These two cannot be added, therefore they must stay how they are, and negative 20 square root of x plus 15 square root of y cannot be added. Let's clear the screen and move on to subtraction. Just like with addition, you can only subtract radicals if they have the same radicand. If two radicals have the same radicands, then you can subtract their coefficients. Let's look at an example. Let's say we have 3 square root of x minus 2 square root of x. They have the same radicands. The radicands for both of them is x, so we can subtract their coefficients. The coefficients of the first one is 3, the coefficient of the second one is 2. 3 square root of x minus 2 square root of x is 1 square root of x, because 3 minus 2 is 1, which is just equal to the square root of x. You don't need to write a coefficient of 1. Let's do another example. Negative 6 square root of z minus 2 square root of z. Do they have the same radicands? Yes, they do. They both have radicands of z, so we can subtract their coefficients. Minus 6 minus 2 is minus 8. Negative 8 square root of z. One last example for subtraction. Negative 5 square root of y minus 2 square root of z. Do these two have the same radicands? They do not. The radicand of the first one is y, and the radicand of the second one is z. Therefore, these cannot be subtracted, and they must stay how they are. Let's clear the screen and move on to multiplication. When you want to multiply two radicals, all you need to do is bring them into the same square root sign. So let's say I have the square root of x times the square root of y. They don't need to have the same radicands or the same coefficients. All you need to do is write the square root of x times y. Let's do another example. Square root of x times the square root of y times the square root of z. All you need to do is write the square root of x times y times z. Very simple. There is something special though if you're multiplying two of the same radicals. Square root of x times the square root of x. Since you're multiplying the same thing, it's really the square root of x squared. When you have a square root symbol and you have a square, these two cancel each other out. The square root cancels out with the square, and you're left with just what's inside, so you're left with x. Let's try another example. Let's say we have the square root of z to the third, and we're multiplying that by the square root of z to the third. What we're really doing is writing the square root of z to the third. We're squaring that. And the square root symbol cancels out with the square, and we're left with just what's inside, which is z to the third. Let's clear the screen and move on to division. When you want to divide two radicals, you could do a similar thing to what you do for multiplication and bring them into the same radical sign. Let's say we have the square root of x divided by the square root of y. Just like by multiplication, they do not need to have the same radicands. It'll be easier to visualize as a fraction. So the square root of x over the square root of y. What we can do to this is bring it into one big radical sign, square root of x over y. Now, when might this be helpful? Let's say we have the square root of x cubed divided by the square root of x. Let's rewrite it as a fraction, the square root of x cubed over the square root of x, and let's bring them into the same radical, the square root of x cubed over x. Now what we could do is we could simplify this like a regular fraction. We have the square root of x cubed over x to the 1. So since we have an x with a bigger exponent in the numerator, they have the same bases, and x with a bigger exponent is in the numerator, we can subtract 3 from 1 from 3, x to the third minus x to the 1, and leave it in the numerator. So that becomes x squared over 1, which is just the square root of x squared. And soon we'll learn that you can simplify the square root of x squared to x. Let's try one more like that. Let's say we have the square root of y squared divided by the square root of y to the 5th. Let's rewrite it as a fraction. The square root of y squared over the square root of y to the 5th, which is equal to a big square root of y squared over y to the 5th. Now, we can simplify y squared over y to the 5th because they have the same bases. They don't need to have the same exponents for division. And this becomes, we do the bigger one minus the smaller one, and we leave it in the spot of this bigger one. The bigger one in this case is in the denominator, so we do 5 minus 2, it's 3. Y to the 3, and we leave it in the denominator. Since we have nothing left in the numerator, it just becomes a 1.